Okay, today is October 25th, and we have 4 questions for warm-up. Our first question says negative 1.8 plus 3.5, which comes right from section 2.2 in our Math Links textbook. What do I have more of, the negatives or the positives? The answer is I have more positives. The difference between them will be subtraction. Borrow. I have 1.7 more positives, and therefore my answer is positive 1.7. In the next question, subtraction of fractions requires common denominator, so we're going to create this here. That's going to stay the same. This is going to become negative 6. Once we have that, the rule you learned in grade 7 was keep your denominator and subtract your numerators, which when I use keep, flip, change, will become negative 6 plus negative 7, which is negative 13/8, which is your answer. Since that's improper, you will always change it back to negative 1 and 5/8. Your third and fourth questions are just your basic Pythagoras. So Pythagoras said that this leg and this leg make up a 90-degree angle in a right triangle. And when he was playing around with numbers, he realized that if he not only uses the side length, but rather the area of a square or an imaginary square that would be attached to there, and instead of thinking about 10, thought about the area of the square that would be attached to those. The area of this square would be 9 because it's side squared, which is 3 squared, which is 3 times 3, which is 9. This would be side squared for area, which would be 10 squared, which is 10 times 10, which is 100. So the area of both of those respective squares would be 9 and 100. And what he realized was if you put a square on this third side called the hypotenuse, the area of the two squares attached to the legs will always equal the area of the square attached to the hypotenuse. So therefore, we know that that square will have an area of 109. And therefore, the side length of x will be the square root of 109, which is your answer. Because I wanted the exact answer, not an approximation. If I guess what that would be, what we have been doing before is we're saying, well, the square root of 100 is 10. The square root of 121 is 11. 109 is just shy of the middle, right around there. And if I was guessing, I would say maybe 10.4. Would you agree with that estimation? Maybe 10.5. Take my calculator just to see what it would be. 109 square root, meaning what number multiplied by itself is 109. It's approximately 10.44, which is, again, what kind of number is this one? Because it doesn't repeat. It's irrational. It does not repeat a pattern, and therefore does not fall under our categories of rational numbers, which we have been learning this year. So we're going to say the exact answer for x, the exact length of it is the square root of 109. Its approximate length is 10.4. Does that make sense? I know, smart guy. So Pythagoras, by using that same logic again, by putting squares on here, this area is 9. This area we don't know, but this area is 100. What must this area be if it's on the leg? It must be 91, correct? Because this area plus this area has to equal that 100. So therefore, the area of this square is 91. And if the area is 91, what's the length? The square root of 91. Okay? If I was to then estimate what that is, I could use a number line. The square root of 81 is 9. The square root of 100 is 10. The square root of 91 is almost smack dab in the middle, right? Would you agree? Square root of 91 would be roughly there. And therefore, if I'm guessing, would you all agree 9.5 is a pretty good guess? If I took my calculator and said, what is the square root of 91? What number multiplied by itself is close to 91? 9.539392014, 016, whatever. So those are your answers to this question.